Hi there everyone, welcome back to my channel. Now for our lesson this session, we will be having patterns and sequences. Patterns refer to usual types of procedures or rules that can be followed. Patterns are useful to predict what came before and what might come after a set of numbers that are arranged in a particular order. This arrangement of numbers is called a sequence. 3, 6, 9, 12, 15 are numbers that form a pattern called a sequence. Now let's examine further the sequence. What pattern do you see? That's totally right. Adding 3 to get the next number. So meaning the pattern is simply plus 3. This is the term-to-term rule or the pattern that we are looking for. And take note, this is a sequence. And this sequence consists of numbers. And these numbers are called terms. So 3, 6, 9, 12, and 15 are called terms. And this one, the number 3, is what you call the first term. This one is what you call the first term. In symbols, we will be having a sub 1 for that. Same thing with the second term. We will be having a sub 2 for the second term, a sub 3 for the third term, so on and so forth. Now, let's concentrate on searching for patterns first. Let's try these. Let's find the term-to-term rule or simply the pattern for these sequences. Number 1, 3, 7, 11, 15. What do you think is the term-to-term rule? A while ago with our example, it's plus 3. That's what you call the term-to-term rule or the pattern. Now for this number 1 item here, what is the term-to-term rule? That's totally right, plus 4. So if you're gonna check, we have 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 4 is 15. Now, if I'm gonna be looking for the next number, what would that number be? The number, that's totally correct, the number 19. Okay, let's move to our second item. What is the term-to-term rule for this? Okay, plus 5 is right. So we will be having plus 5. This is plus 5 to get 10. Plus 5 to get 15. So the next number would be the number 20. That's totally right. Let's have our third item. 16, 13, 10, 7. What is the pattern or the term-to-term rule for this? Okay, that's minus 3 or negative 3. So I'm going to have minus 3. I'm going to be getting 13. 13 minus 3, that's 10. 10 minus 3, that's 7. So the next term would be 7 minus 3. You will be getting 4 for that. Let's have number 4. 3, 1. Negative 1, negative 3. What is the term-to-term rule or the pattern? Okay, that's correct. That's negative 2 or minus 2. So upon checking this, minus 2, that's right. Minus 2, that's correct. Negative 1, you'll get negative 3. For this one, the next term would be negative 5. Because negative 3 minus 2 is negative 5. Let's have our fifth example. 1, 2, 4, 8, 16. Oh, no, it's not plus 1. It's not plus 2. Okay, it's times 2. So you will be having times 2 for this to get positive 2. 2 times 2 to get positive 4. 4 times 2 to get 18. No, I mean 8. 8 times 2 to get 16. So the next term would be 16 times 2. That will be 32. Okay? Let's have number 6. You have there 2, 3.5, 5, 6.5. What will be the next number? And what will be the pattern first? The pattern is, sir, okay, plus 1.5. That's correct. So if you will be checking, this is 2 plus 1.5. This is plus 1.5. This is plus 1.5. So to get the next number, plus 1.5, you will be having 8 will be the next number. That's totally right. Let's have our last item for this one. Searching for patterns. Number 7, 0.01, 0.1, 1, and 10. What could be the pattern for this? You think carefully, analyze the numbers. Think of a pattern, a term-to-term rule that applies to all the terms. That's totally right. Times 10. So if I'm going to multiply this by 10, I'll be getting 0.1. 0.1, multiply that by 10, I'll be getting 1. 1 times 10 is 10. So the next term is simply 10 times 10. That will be 100. Okay, now, there are so many kinds of sequences, and one of those kinds of sequences is arithmetic sequence. And the other kinds will be discussed later on as we move on with our lesson this school year. Okay? Now, what is an arithmetic sequence? It's a sequence of numbers in which the difference between any two consecutive numbers or expressions is the same. So if I'm going to go back to our previous exercise, which among these 7 items is an example of an arithmetic sequence? So if I'm going to redefine it, arithmetic sequence is simply adding a constant number to get the next term. So, okay, that's totally right. Number 1 is an arithmetic sequence because it's plus 4. Number 2 is an arithmetic sequence. It's plus 5. Sir, number 6 is an arithmetic sequence, plus 1.5. What about negative 3 and minus 2? Isn't addition just the opposite of subtraction? So I will also include subtraction for this. So plus negative 3 plus negative 2. So these numbers here, these numbers, the number that is being added, meaning the constant number, you call this the common difference. Okay? So just take note of the terms I am using now. The number being added, whether it's positive or negative, that is the common difference. Now, let's go back to our arithmetic sequence. Find the next 3 numbers of these pattern or this sequence. Now, let's have this one. Let's analyze the sequence first. What is the pattern for 7, 12, 17, and 22? That's totally right. The pattern is simply adding 5. So take note, the first step that you're going to do is look for a pattern. The rule. The term-to-term rule. Okay, let's proceed. Let's verify that. So let's start with this one by verifying whether it's really plus 5. 7 plus 5 is 12. 12 plus 5 is 17. 17 plus 5 is 22. Therefore, the next term of the 22 will be 22 plus 5, that is 27. There you go. This one. Then 27 plus 5 is 32. There you have it. And lastly, 32 plus 5 is 37. Therefore, the next 3 terms are 27, 32, and 37. Let's have another example. Let's have this one. You have here 45, 42, 39, and 36. Let's look for the pattern. And you have noticed that it's a decreasing sequence. Therefore, the pattern is simply subtracting 3 or adding negative 3. Okay? When you subtract 3, it's the same as adding negative 3. Do you agree with me? Okay, that's totally right. You agree with what I said. Now, let's continue. We have 45 plus negative 3, that's 42. 42 plus negative 3, that's 39. 39 plus negative 3, that's 36. 36 plus negative 3, that is 33. That's totally right. Now, what about the next number? We have 33 plus negative 3, that's 30. 30 plus negative 3, that is 27. So the next three terms are 33, 30, and 27. Okay? Now, let's now have the arithmetic sequence formula. Sir, why is it that we will be having as a formula when in fact we will be only adding numbers like plus 3, plus 4, minus 3? Now, this is my concern. Now, what if we are looking for the 75th term? So you will be adding plus negative 3 until you reach the 75th term. So we have a formula for practical reasons. Okay? Now, to make this simple, for the solution part, this will be our formula. Let's identify the parts of the formula first. So you have there a sub n, that is the nth term. A sub 1, I mentioned it a while ago, that's the first term. So you already know what a sub n is. For example, we are looking for the 77th term. So I will be writing this as a sub 77. So a sub n is simply a sub 77. The first term, you already know that. N is the term number. Now, for example, I am looking for the 77th term. What is n here? N is equal to 77. That's totally right. So whatever is the subscript of your a, that will be your n, and that will give us 77. The common difference, that's D. Okay. Now, let's have our example. Let's make use of the formula to find the 25th term of the sequence. 4, 7, 10, and 13. Now, let's introduce the formula first. So, my question is, what is a sub n in the problem? Very good. It's a sub 25. So, I'll be writing a sub 25 for our formula is equal to, so this is already correct. Write down equal to a sub 1. What is the first term? Sir, the first term, okay, it's the number 4. So write the number 4 there. Plus. So okay, na tong first term plus. What is a sub n? Sir, it's 25, the subscript. So that will be your n. That's 25. Minus 1, and the common difference, how much did we add to get 7, to get 10, to get 13? Okay, the common difference is positive 3 or 3. So we will multiply this by 3. Now, in this one, we will be having PEMDAS for this. So you start with what is inside the parenthesis. So you'll be having 25 minus 1, that's 24, times 3. Then you proceed to multiplication. So I started with this. I got 24 for that. Then I multiply 24 and 3, these two, to get 72. So 72 and 4, you add those numbers. The 25th term is 76. Okay, there you have it. Now, let's have another item. What if I'm looking for the 32nd term for the sequence? 79, 75, 71, 67, and 63. So, let's identify first the parts of the formula. We have a sub n, that's a sub 32. Okay, so let's write down a sub 32 is equal to, the first term is what? Look at the sequence. What's the first number there? The number 79. So the number 79 is the first number. That is the first term. So 79 plus. Okay. Okay. What is n here? What is the value of n? Very good. It's 32. the value of n is 32 minus 1 times the common difference. Now, you have noticed that our sequence is decreasing, so expect that your common difference is the negative number. So the common difference is negative 4. That's totally right. Negative 4. So I'll be having 79 plus 31. You subtract the 2 first inside the parenthesis times negative 4. Now, what is 31 times negative 4? So 79 plus, that will give us how much? Again, what is 31 times 4? It will give us 124. So we have plus negative 124. Now, what is 79 plus negative 124? Okay, that will give us negative 45. And that is our 32nd term. So that ends our first part of arithmetic sequences and series. Till next time.